All right, so this is SAT Systems of Equations A. Your hints or your walkthrough, your guide, whatever you want to call it. The pixels are showing up really large here. I don't know what the deal is with that, but I'm just gonna start. I've worked them all out, so it should be pretty quick to talk through them. I can make the videos shorter, make you guys more likely to watch them. Okay, so 108 pounds of produce, Z pounds of zucchini, C pounds of cucumbers. So if I add up the Z and the C, then I should be getting 108. And then the zucchini is $1.69 a pound, so put that next to the Z. The 99 cents goes with the cucumbers, and that should get you where you need to go. Number 2, you got to solve for X. So you could do this a bunch of different ways, but if you want to solve for X, what you want to do is eliminate Y. And if you eliminate the other thing first and have to go back and plug in, it'll still work. It just takes you a little longer. So try to think about the fastest way to do it. So if I want to find X, I want to eliminate Y. So that's why I decided to multiply this bottom equation by 2. And then I got this over here. And then I added these two. The Y's go away. And I get 2x equals 36. And then you can find X from there. Number 3, if there's going to be no solution, or if it's going to be all real numbers, this works for both. You want everything on the left-hand side to be in the same ratio. So I probably chose like the worst possible way to do it, actually. So I went 2 over 4 equals 3 over C. But you could actually do it this way. So now that I'm looking at it again, I think I would go 2 over 3. I don't know if it really matters. Equals 4 over C. I don't think it makes much difference, actually. But then cross multiply and find out what C is. Number 4, again, I think most of you guys are pretty solid at this, but just try to make sure you can do it as quickly as you can. If I want to find X, my easiest, fastest way to do that is to eliminate Y. So if I want to eliminate this, I want to get these two to match up. So this is already a negative 2Y, so I decided to make this a positive 2Y by multiplying the top equation by 2, which got me this. And then 2x plus x is 3x. 2y and negative 2y cancel. 42 and negative 3 is 39, and you can find out what x is from there. Number 5, again, if you want to find x, try to eliminate y. And this is about as straightforward as it can get, although the 0 messes people up sometimes. But I can just add these right now. 2x plus 2x is 4x, negative 4 plus 4 is 0. And then some people get confused here and think it's no solution or aren't quite sure what to do. But divide by the number next to the x, and you know, if I had $0 and I want to divide it evenly among 4 people, everybody gets $0. 6 is a little tougher. 6 is a quadratics problem, which I'm going to go through quadratics, and I'm going to go through, like, I don't know how to do it with quadratics. Is there another way you could get me to get this to work? And I'm going to show both. If they intersect, they're going to be equal. And you can think about this like substitution too. So if y equals this stuff and y equals that stuff, then these two stuffs must be equal. So I set them equal. On the right-hand side over here, the way I got this was to FOIL. So I'm doing first, outside, inside, last, and combining like terms, and I get this. And then as soon as I have a quadratic, I want one of the sides to be 0, and I want everything on the other side. So I subtracted this 2x over here to go with the negative x that was already over there. It gave me negative 3x. I moved that 4 over by subtracting to go with the negative 6 that was already there. That gave me negative 10. And then we're trying to factor, which we haven't done in here yet, but I think you guys have done in advanced algebra and algebra. So we're trying to find two numbers that multiply to be negative 10 and add up to negative 3. So I got negative 5 and positive 2, because if I multiply those two together, I get negative 10. And if I add those two together, I get negative 3. And then the solutions are actually the opposite of what is in the parentheses. So I got 2 x values here, 5 and negative 2, but those are just x values. So I got 5, comma, and negative 2, comma. And the way I find the y values is go back and plug in. So if I plug 5 in up here, I get 14. If I plug negative 2 in, I get 0. So those are the 2 intersection points. C is a really tricky answer because you get all the way down here and you're like, oh, cool, that 5, negative 2, I got those. Those are 2 numbers. I see those there. And you circle it, but it's not, these are 2 x values. So this is like a coordinate. So there's 2 coordinates you could choose from. And the only one that we see there is that one. The other way you could do this is plug in. So like if I plug in 5 and 14 to the top equation, it makes it true. And if I plug in 14 and 5 to the bottom equation, this would be 2 times 7, and that makes it true. So because plugging it in makes both the equations true, you can get there that way also. Number 7 is kind of cool. You could do this like the hard annoying, I don't know, hard annoying is probably extreme. You could do this the normal way. So I would probably I'd probably multiply the bottom equation by a positive 3. And then I could add everything up and cancel it. But there's a super cool trick in this I wanted to show you. So they're asking for 100x plus 40y. Well, if you add up these two equations, this is just a trick that works sometimes. I get 5x plus 2y. Well, if I take 5x plus 2y and I multiply it by 20, I get 100x plus 40y. And then I got to multiply this also. So 20 times 60 is 1200. 20 times 61 should be 1260. I'm feeling unconfident about that. I'm going to check a calculator. Well, whatever. You guys can figure that out. But multiply 20 times 61, and then you know that 100x plus 40y equals that number. And that's what you're trying to find is 100x plus 40y. So you kind of got there a cooler way. Number 8, this is substitution. It does mess people up because it like almost looks too easy. But I know x is 2, so I can take that 2 and plug it in the top equation in place of x. That gets me here, and then you can just you can solve that. You know, that's 6. Subtract 6 from both sides. Number 9, we're writing an equation and then plug it in. So $3 for a slice of pizza, that's 3p. Calzones, $4. 4C, now I want a calzone, that sounds delicious. $51, so that's how much they spent. They bought 6 calzones, so you can just throw 6 in for C and solve that. Number 10, there's a couple ways to do this too. So one of the ways where I've showed you guys before is graph it, and graph it by finding the intercepts. So what I did in this one was take 5 divided by the number in front of the x, and that's going to be my x-intercept. So my x-intercept should be 5. 1, 2, 3, 4, 5. There's nothing on this one at x equals 5. There's nothing on this one at x equals 5. So I'm done, basically. Just because the way I chose to do it, I just got lucky. But I'm going to keep going and explain why everything else matches up. So 5 divided by the number next to the y would be 1. That's your y-intercept. So that's this line here. This bottom one, -4 divided by the number next to the x, so that's -2, that's our x-intercept. -4 divided by the number next to the y, so -4 divided by -1 is 4, that's my y-intercept. And those are my 2 lines. Another way I looked at it was I doubled I multiplied the top equation by -2 to get here. And then when I add that up with the equation below, the x's go away, I get -11y and -14, and I can solve that and get this fraction, and it's correct, it's just confusing because it's a fraction, but this is like a little bit bigger than 1, so where these intersect should have a y value a little bit higher than 1, and this one does, so it's just another way to kind of confirm it, is all.